right, let's get mathy. So we've talked about how to recognize a saturated solution. Now we want to talk about how to calculate solubility. So solubility, S, is referred to as molar solubility because it's represented by or measured in moles per liter or molarity, right? It's the same units as concentration. It's the amount of moles of solute dissolved in 1 liter of water. So sometimes we will call this specifically molar solubility to remind ourselves that you can dissolve moles per liter of water versus just the word soluble, which could be grams per liter, right? So specifically molar solubility is the moles of solute dissolved in 1 liter of water. For example, if we know that the concentration of hydrochloric acid is 12 molar, that means that 12 moles of hydrochloric acid is dissolved in 1 liter of solution, or dissociated because it is a hydrochloric acid. It's an ionic species. Okay. What I want to do is write the molar solubility of 5 moles of sodium chloride dissolved in 2 liters of water. Well, this should feel kind of good. It's like finding concentration, right? So the concentration of sodium chloride would be 5 moles in 2 liters of water, which would give us a molar concentration of 2.5. Now, careful, sig figs would make us write 2 moles per liter, or 3 molar. All right, next one. It is found that 1 liter of saturated silver bromate contains 1.96 grams of silver bromate. What is the molar solubility? Now, this shouldn't feel any different than doing concentration, right? It's just that we're calling it a different thing. So for this one, we're starting with 1.96 grams of the silver bromate in 1 liter. And then we would do the conversion from grams to moles. So we know that 1 mole of silver bromate is what? Well, silver bromate is made up of 1 silver. So the molar mass of 1 silver is 107.9, as well as 1 bromine. 1 bromine weighs 79.90 moles per gram. And then you've got 3 oxygens, and each of those is 16. So the molar mass of silver bromate is 235.80 grams per mole. So we'd say that 1 mole is 235.80 grams, and then we just have to plug that into our calculator. So we would have 1.96 divided by 235.8, which would give us 0.008. We were kind of limited by this 1 liter, so 0.08 moles per liter of the silver bromate, or molar. Okay. What if we wanted to go the other way around? So what if they gave you molar solubility and you wanted to express this in grams per liters, which we will learn eventually is just solubility, not necessarily molar solubility. So if you're starting with 1.37 times 10 to the negative 3 moles per liter of this lead iodide, we want to change it to grams per liter. So this time we'd put moles on the bottom. 1 mole of the lead iodide weighs how much? Well, lead iodide is made up of 1 lead molecule, which weighs 207.2, and 2 iodines, which is 2 times 126.9, which would give us an overall molar mass of 461.0 grams per mole. So then I would put in here 461, and then I'm going to plug this into my calculator. So 1.37 EE negative 3 times 461. And then for this one, I can answer to 3 sig figs, so I'm going to put 0.632 grams per liter. And we summarize this later, but this is solubility, but not molar solubility. And then the last thing I want you to be able to do here is express this in terms of per 100 mils instead of per liter. It is a good skill to be able to change your units into different things. So if I had 0.63157, because I'm going to go back to unrounded, although it doesn't really matter for this, grams per liter, and I want to go per 100 milliliters. Something you might want to do is convert from liters into milliliters. So 1 liter is 1,000 milliliters. And then if I want to go per 100 milliliters, I can just times that by 100, right? So what that would leave me with is the amount per 100 milliliters. So I can do that divided by 1,000 times by 10, and I would get 0.0632. I think I said times by 10, I meant 100. 0.0632 grams per 100 milliliters. Now you don't have to do that. Me personally, I know that 100 milliliters is 1/10 of a liter, and so I would just divide by 10, right? So you don't have to do this whole conversion to milliliters and then change it to how many milliliters you want it to be. You choose, right? As long as you can understand how to convert. All right, so what about this question? I'm going to let you pause the video. It is found that 250 milliliters of a saturated calcium chloride contains 18.6 grams of calcium chloride at 20 degrees Celsius. What is the molar solubility? So really all we're checking here is that you know what molar solubility is. You know that we're looking for moles per liter. So pause the video and give this a go. I want you to convert this from grams per maybe milliliter to moles per liter. So I would start with 18.6 grams of calcium chloride, and then I would right away divide by 250 milliliters. So now I'm in grams per milliliter, and then I'm going to convert my grams to moles. So I know that 1 mole of calcium chloride weighs how much? Well, calcium chloride is made up of 1 calcium. Each calcium, have to look this up on my sheet. 1 calcium is 40.08. And then I've got 2 chlorides, so 2 times 35.45 would give us an overall molar mass of 110.98. So I'm going to put in that. Then now I'm in moles per milliliter, and I want to go moles per liter. So then I'm going to say that 1,000 milliliters makes up 1 liter. So now I will be in moles per liter. So into my calculator, I'm going to put 18.6 divided by 250, divided by 110.98, and then times by 1,000, which is going to give me 0. Now I was limited by the 2 sig figs there, so 0.67 moles per liter would be the molar solubility. And again, there's different ways of doing this. I didn't have to convert milliliters into liters. Instead, if I had wanted to, right, I could have just put in 250 milliliters as 0.25 liters, right? And then I don't have to do that final conversion into liters. You pick your poison. All right, not pause the video. Now it's time to go practice.